or good afternoon if you're watching this after noon, obviously. So the other day we talked about finding absolute max and mins. And we started by finding critical numbers, and we took those and endpoints and plugged them into the original function and found the biggest output and the smallest output. In that lesson, I also said we are going to start talking about finding relative max and mins as well. I talked about what they were a little bit, but I said this lesson is all about how we find relative max and mins. So I have this graph right here, this nice looking graph, and I highlighted a few points. I have a relative maximum right here, a relative min, and a relative max. So a relative max or min is basically if there's a highest point within some sub-interval, like at any hill, any valley, any peak, anything like that. And I want you to notice what's true about the derivative at all of those relative max and mins. Okay, so I'm going to start right here at these critical numbers that I've highlighted, C1, 2, 3, and 4, and 5. And the derivative right here at C1 would be 0. The slope right there is 0. The derivative right here would also be 0. The derivative right down here would be 0. The derivative here would be undefined because it's a sharp turn. Derivatives don't exist at sharp turns, so undefined. And the derivative here is 0. Now what I want you to notice is this. Notice that where the relative max and mins occur at these three places, they have to happen at critical numbers. So relative max and mins only occur at critical numbers. But the other thing I want you to notice here's a critical number, and here is a critical number. These are not relative max or mins. So just because they have to be at critical numbers doesn't mean every critical number will be a relative max or min. So what we're going to have to do today, we are going to start every problem by finding critical numbers, just like last process. Our analysis is going to change a little bit because here's what we're going to be looking for. So if you look down here within the intervals, okay, notice right here from A to C1. From A to C1, this function is always increasing, which means its derivative is always positive. Where a function is increasing, its derivative is positive or greater than 0. So over this entire interval, f prime is positive. On this entire interval, since this f of x is increasing this whole time, its derivative is also positive, greater than 0. Here, the function's decreasing, so its derivative is negative. Here, the function's increasing, so its derivative would always be positive on that interval. And then decreasing and decreasing again, so less than 0, less than 0. The reason I'm pointing that out is this. I want you to notice what happens where the relative max and mins occur. Notice what happens to f prime, the derivative. So right here, at this maximum, notice what's happening to f prime. On this side, f prime is positive, then right on the other side, f prime is negative. So wherever f prime changes sign from positive to negative, that is where a relative max is going to happen. Notice here, f prime is negative, then here f prime is positive. So where f prime changes from negative to positive, that's where a relative min occurs. And that's what we're going to be after. Because if you notice right here at this critical number, f prime's positive, and then it's positive again. So we don't actually have a relative max or min because f prime did not change sign. So this is actually the first derivative test. This is going to be our analysis. I don't know why there's a black dot right here, but I can't get it to go away. So I hope that's not bugging you. And it probably wasn't until I just pointed it out, and now you're going to fixate on it. So sorry about that. So the first derivative test says this. If f prime changes from positive to negative at x equals c, just like right here, from positive to negative, then x equals c is going to be a relative max. On the flip side of that, if f prime changes from negative to positive at x equals c, so right here, from negative to positive, then x equals c is a relative min. And think about why. You know, if f prime changes from positive to negative, that means f's going up, and then f's going down, and that's creating that maximum effect. So let's do some examples in how we, given a function, find relative extrema. Okay, So it all begins, just like with absolute max and mins, it all begins by finding the critical numbers. Critical numbers are where f prime is 0 or undefined. So I'm going to start by finding f prime. So 3 comes out in front, 3/4 x squared minus 3. And I want to know, where does this equal 0? So I'm going to add 3. Multiply both sides by 4/3. And square root. And remember, whenever you square root, you have to put plus or minus. So plus or minus 2. Now, these are the critical numbers. These are the only two numbers that make f prime equal 0. However, that doesn't necessarily mean these are relative max or mins. So here's the analysis. Here's where this lesson now differs from finding absolute max or mins. We're actually going to use what's called an f prime sign chart. Here's what I mean by that. So we take our critical numbers, and we're going to put them on a little f prime sign chart. And what we're after is this. These are going to be like test intervals, okay? These are the only two places where f prime can change sign. And what that means is any x value, any number we would plug in less than -2, f prime will always be the same sign, whether positive or negative. Between -2, f prime will always be the same, whether positive or negative. And then on the other side of 2, same thing. So we're actually going to take numbers within each interval, plug them into f prime, and see if we get a positive or negative output. Here's what I mean by that. I'm going to plug a number in less than -2. Now, you might be thinking, let's use -3, which is all well and good. I personally would not choose -3. I would plug in like -1 billion. Now, I'm not joking when I say that, and I want you to understand why. I would plug -1 billion into f prime. And the reason I would do that is this. The number we get out does not matter. What matters is if it's positive or negative. So think about if I would plug -1 billion into f prime and square it. We would get some giant positive number. Some giant positive number times 3/4 is still a giant positive number. A giant positive number minus 3 is a positive number. So I don't actually have to think very hard to realize that this right here to the left of -2 is always going to be positive. F prime is always positive. What that means about f is always increasing till it gets to -2. Now I pick a number between -2 and 2. So when you can use 0, I would use 0. I'm going to plug 0 into f prime. And I get -3. So f prime is negative in this interval, which means f is always decreasing. Then I'm going to plug in a big positive number, so a billion. A billion squared times 3/4 minus 3, it's positive. These arrows right here are not required. I do this because this gives me a visual, like notice f's going up, then it's going down. So I can actually see that maximum occurring right here at -2. And then f's going down, then up, I can see that minimum occurring right here at 2. So here's how I write my answers. If I was doing like a free response problem, here's what I would say. I would say f has a relative min at x equals -2. Oh, should be a max. My bad. Crap. I'm the worst. Has a relative max at -2. And then oftentimes it's going to say justify or explain your reasoning. And I would say because f prime changes from positive to negative at x equals -2. From positive to negative at x equals -2. That would be my justification. And you don't need to say more than this. In fact, don't, because sometimes you get too wordy and then you might say something that's incorrect. This is all you need to say. You don't need to say then, like, which means that f was increasing till it got to -2 and then it started to decrease and that's what created the relative max. Like, you don't have to say all that. This is your answer. This is your justification. That's all they're looking for. And then f also has a min right here at 2. So f has a relative min at x equals 2 because f prime changes from negative to positive at x equals 2. So notice that it is a different procedure when we're finding relative max and mins versus finding absolute max or mins. Absolute, we would take our critical numbers and then our endpoints and plug them back into the original function and literally look for the biggest number. Relative, we're looking for a sign change on f prime. So we do a f prime sign chart. All right. Next. Example 2. So if you look at example 2 and you look at example 3, here's where you need to start being careful and not fall into traps of just following rote processes. Notice that these look very similar. They look like already factored or whatever, but this one they're giving you f prime, and this one they're giving you f. So we have to treat these problems differently. Like this says, at what values of x does f have a relative max? So think about how we start. We start by finding where f prime is 0 or undefined. Well, they're already giving me f prime, and they already factored it for us. I can find the zeros of f prime right here. My critical numbers would be 0, 3, and -1. Those are the numbers I'm going to put on my f prime sign chart. Now, a couple of things. When you put your numbers on there, make sure you put them from least to greatest. Now we have some mental math to do, and I hope this makes sense without me actually like teaching it in person, but here's what I like to do, okay? We need to plug numbers from each of these intervals into f prime and think about what the output would be, what the sign would be. And here's what I do. And this is not a requirement. In fact, they're not even going to grade your sign charts. The graders like on AP and me are not even going to grade this or look at it. This is mainly for you. But what I do is anytime I have factors, I list these factors off to the side, right here like this. And I'll explain why I do this. I do this every time I do these problems. And the reason I do this is, okay, imagine I take a number less than -1. So let's use -100 or whatever. Well, if I plug -100 into each of these factors, let's think about what the signs would be. This would be negative. This is always going to be positive because I'm squaring it. This factor would be negative. And then think, if I would multiply a negative, a positive, and a negative together, we would get a positive. That means f prime is always positive on this interval. F would be increasing. Then I'm going to plug in -1/2 in this interval. So this would be negative. This is always positive. -1/2 plus 1 is positive. And if I multiply a negative, positive, positive together, I get a negative. So again, we're just doing sign analysis. The actual numbers don't matter. Plug in 1 from this interval. So I would get a positive, positive, positive. So positive. And then plug in a big positive number. And again, these are all positive. So again, this is not required. I just think this helps organize everything. This question says, at what values of x does f have a relative maximum? So we're only focusing on maximums, and that's happening right here. I can see what f is doing right here at -1. I would say f has a relative max at x equals -1 because f prime changes from positive to negative at x equals -1. Now on the next one, I already kind of pointed it out, but on the next one, they give us f, which means we have to find f prime first on this one. This one gave us f prime. This one gave us f. Always identify what function are they giving me. especially when it comes to graphs. You'll see on the very last example. So I need to find f prime. To find f prime, well, we have two functions being multiplied, so we have to do product rule. So first times the derivative of the second. Well, the derivative of the second, we would have to do chain rule. 2 goes out in front, inside stays the same, reduce by 1, and then multiply by the derivative of the inside, which is just 1. So we could have gotten lucky and not gotten the answer wrong, even if we forgot chain rule. But always be chaining, always be thinking about it. Then plus the second one times the derivative of the first one, which is just 1. So here's where we are. Now, in person, I called on students and I said, okay, we need to figure out what makes this equal 0. And every class I asked, students said 2 and 3, because those are the things you see in parentheses. And I said, no, it's not 2 and 3. I said, in fact, it's 3 and 7/3. And, that got a reaction out of the class because you don't see 7/3 anywhere. Well, if you think back to last chapter, I alluded to this, but I said, what happens in this chapter, we find a derivative, but then when we want to figure out what makes this equal 0, we have to factor. You can't solve equations unless you have them factored. So if you notice, each of these terms have x minus 3 in common. So I'm actually going to factor out x minus 3 as my GCF from each of these terms. If I factor out x minus 3 from the first one, I would have 2x minus 4 left when I distribute. Plus, I would still have an x minus 3 left from the second one. And then I just clean up that second set. Now I can find my critical numbers. It would be 3 and 7/3. So again, we can't solve unless we factor. Now I'm going to do my f prime sign chart. So I'm going to put, 7/3 is less than 3, so I'm going to do 7/3 and 3. And I'm going to plug numbers in, but here's the thing. I'm not going to plug my numbers in to this line here because that would be too hard mental math to multiply stuff together, add, whatever this is. I'm not going to do that. I'm actually going to plug it in to where these factors are. So I'm going to plug my numbers in. I notice I have 2 factors, so I list my factors. Not a requirement, but this helps me a ton. So I pick a number less than 7/3 to plug into each of these factors. So I'm going to plug 0 in. So this would be a negative and a negative, which means positive. F's going up. 7/3 is 2 and 1/3. So we could plug 2.5 into this interval. So 2.5 minus 3 is negative. 3 times 2.5 is 7.5. 7.5 minus 7 is positive. And if I would multiply a negative and a positive, we get a negative. And if I plug in a big positive, these would both be positive. So again, this one asks for a relative max. I would say f has a relative max at 7/3 because f prime changes from positive to negative at 7/3. So just like we answered the other ones. 4, very similar. I'm actually, for the purpose of time, just going to skip 4, but I want to look at this next one. This next one is very interesting. One of the most common problems you're going to come across on FRQs especially, but anytime they give you a graph, almost always. So, okay, before I spoil this, look at the graph and look at the question. It says, identify all intervals where g of x is increasing or decreasing. Justify your answers. Now, the first thing a lot of students do, they're like, well, this is increasing all the way till it gets to 0. That was easy. And then it's decreasing till it gets to here, and then increasing, and then decreasing. But notice what this is the graph of. This is important. This is the graph of g prime, not g. And this is where we need to start being very careful with what graph are they giving us. This is the graph of g prime. So now we need to shift our thinking. Where this graph is increasing is pretty much irrelevant to this problem. what I've said you have to know at this point. G is increasing where G prime is positive. I want to figure out, where is this graph positive? Positive meaning above the x-axis. G prime is positive from -3 to 1. That's where G would be increasing. G is increasing on -3 to 1 because G prime is positive. Where G prime is positive, G is increasing. Anywhere G prime is negative, so down here and all down here, that's where G is decreasing. So G is decreasing on -infinity all the way till you get to -3, and from 1 all the way till infinity. That's where G is decreasing, because G prime is negative on these intervals. So it gets really tricky because this is the graph of G prime, and we're going to have to get really good at reading a derivative graph. B says, identify the values of x where any critical numbers on G occur. So I'm going to start there. Critical numbers of G are where G prime is 0 or undefined. Where G prime, where this graph is 0, boom, boom, boom. These are where G prime is 0. These are the critical numbers of G at these 3 x values. So I would say the critical numbers of G are x equals -3, 1, and 5. That's where G prime is 0. The second part of the question says, does G have a relative max or min at these x values? Justify your answer. So notice what we did on the other problems. We were trying to figure out, I know it was f prime, but we were trying to figure out, where does f prime change from positive to negative or negative to positive? We could do the same thing with a graph. We need to figure out, at these critical numbers, does G prime change sign? And at this one, it does. Notice right here, G prime is negative, and then over here, G prime is positive. G prime changes from negative to positive right at -3. That creates a minimum. So G has a relative min at x equals -3 because G prime changes from negative to positive. You need to be very careful with how you say your words. Negative, positive versus increasing, decreasing. Those all mean different things. Right here, G prime changes from positive to negative. That's a maximum. So G has a relative max at x equals 1 because G prime changes from positive to negative. And then lastly, right here, we had a critical number, but notice G prime was negative, and then G prime was negative again. So G would be decreasing, and then it'd be decreasing again. There's no relative max or min at this critical number. So it has to be crossing the x-axis, changing sign. Last one. So if this is the graph of G prime, and they're asking about G double prime, well, this is asking about the slope of this graph at 2.5. So right here at 2.5, this is saying, what's the slope right here at this point? And it's a horizontal tangent, so the slope is 0. All right. Hopefully that made sense. If not, reach out. Peace.